In our activity of angles of isosceles triangles, we learned that the base angles of the isosceles triangle are congruent to each other. And so what we're going to do in these three pictures underneath, we're going to practice calculating the measure of each missing degree in the triangles below. Okay, so I have to remember where the vertex angle is and where the base angles are. Okay, and the base angles, we said before, are always located across from the two congruent sides. So looking at my first picture here, all right, this angle up here is 70 degrees. And if I go across from the two congruent sides, so across from that side and across from this side, these are my two base angles. The base angles are missing, which means that this is the vertex angle. So in order to get the measure of the base angles, what I'm first going to do is take the measure of the vertex angle and subtract it from 180, because I know in a triangle all three angles add up to 180 degrees. So if I do 180 minus 70, well, I'm going to be left with 110. That means that these two angles together are 110 degrees. And since the base angles are congruent to each other, to get the measure of each one, all I need to do is take 110, divide it by 2, that equals 55. So that means that each base angle in this isosceles triangle is 55 degrees. In example 2, I can see that this angle is 50 degrees. And I also see that that's one of the base angles since it's across from one of the congruent sides. Okay, if I go across from the other congruent side, this angle down here is going to be my other base angle. And since the base angles are congruent to each other, this angle down here must also be 50 degrees. That means I have to figure out what my vertex angle is. And again, I know in a triangle that all three angles have to add up to 180. So I have 50 plus 50, my base angles, which is 100 degrees. And then 180 minus 100 means that my vertex angle must be 80 degrees. Okay. Finally, in picture number 3, again, I have this angle up here is 65 degrees. If I look across from the two congruent sides, here and here, these are the base angles which are missing, which means that this angle up here is the vertex angle. So again, I'm going to subtract the vertex angle from 180. 180 minus 65 is 115. That means that these two angles together add up to 115. And since they're congruent to each other, I'll take 115 and divide it by 2. Which gives me 57.5. So both of these angles are 57.5 degrees. That base angle and that base angle are 57.5 degrees. In this example, I'm going to use the figure to the right in order to answer questions 4 through 7. Okay, and again, like I've done before, I'm going to reset my picture, meaning that I'm going to treat these as independent questions. They're all independent of each other, so I'll start brand new after each question. In number 4, we're told that the measure of angle 1 is 100 degrees. Then the measure of angle 3 is blank, the measure of angle 8 is blank, the measure of angle 9 is blank. So I'm going to start with angle 1, and I'm going to look at angle 3. Angle 1 and angle 3, they're across from each other from this point of intersection, so they're vertical, meaning they're congruent to each other. So if angle 1 is 100 degrees, well, then so is angle 3, also 100 degrees. Now I need to get the measures of angle 8 and angle 9. And if I look in my diagram right here, there's my triangle. Angles 3, 8, and 9 are in the triangle. And notice the markings that I have here. I have a marking here and a marking here, meaning that this side of the triangle and this side of the triangle are congruent. So this is an isosceles triangle. So if I go across from those sides over at angle 9 and angle 8, these are the two base angles. So that means that angle 3 was the vertex angle, which was 100 degrees. So in order to get these two angles, well, what I'm going to do, I'm going to subtract that 100 from the 180. 180 minus 100 equals 80. And then, since that's the measure of both of the base angles together, I'm going to split 80 in half. which means that both of these angles, angle 8 and angle 9, must each be 40 degrees. In question number 5, it says if the measure of angle 8 is 40 degrees, then the measure of angle 7 is blank. So here's angle 8, here's angle 7. Together they form a straight angle, so they're supplementary angles, so they add up to 180. So if angle 8 is 40 degrees, well, 180 minus 40 means that angle 7 is 140 degrees. In number 6, if the measure of angle 8 is 45 degrees, then the measure of angle 9 is blank, and the measure of angle 3 is blank. Angle 8, angle 9, and angle 3. Those are the three angles again in this isosceles triangle. And remember we said before that angle 8 and angle 9 are the base angles, so they're congruent to each other. So if angle 8 is 45 degrees, then angle 9 is also 45 degrees. Angle 3 then is the vertex angle, so in order to get that, we'll add the two base angles together. 45 plus 45 equals 90. And then to get the measure of angle 3, the vertex angle, we'll do 180 minus 90, which is 90. So angle 3 is 90 degrees. Finally, in question 7 rather, if angle 11 is 70 degrees, then angle 8 is blank and angle 3 is blank. So angle 11, 8, and 3. Angle 11, 8, and 3. Well, angle 8 and 3 are in the isosceles triangle. Angle 11 is vertical to angle 9, which is in the isosceles triangle. So if they're vertical to each other, they're the same. So if angle 11 is 70 degrees, then so is angle 9, which is one of my base angles. Angle 8 is the other base angle. They're congruent to each other, so angle 8 is also 70 degrees. And now we just have to get this vertex angle up here, so I'm going to add my base angles together. 70 and 70 is 140. And now if I subtract 140 from 180, that means that angle 3, my vertex angle, must be 40 degrees. In example 8, they're asking us to find the measure of each angle in the figure below. So I've got angle x here, and this angle is 2x plus 4. And I can already tell that this is isosceles since I have two congruent angles in the triangle. So two congruent angles means I have two congruent sides, which would be here and here. So this is definitely an isosceles triangle. In order to get the measure of all of the angles, well, I know all three angles together add up to 180. So I'm going to take my angles and add them together. 2x plus 4 plus x has a measure of 180 degrees when I add them all together. All right, I'll combine my similar terms. 2x plus 1x is 4x, and then 4 is my only constant. Plus 4 equals 180. Now I'll solve my two-step equation, subtract 4 from each side. On the left, that leaves us with 4x. On the right, 180 minus 4 is 176. Now I'll divide each side by 4. 4x divided by 4 is x. 176 divided by 4 is 44. And this is really nice now because my base angles were labeled with x, so I know that each one is 44 degrees. And now I just have to get my vertex angle up here, which was 2x plus 4. So I'll do 2 times 44 plus 4. 2 times 44 is 88. And then when I add 4 to that, I end up with 92. So this is a 92 degree angle. And again, in order to check, I can just add these three together. 44 plus 92 equals 180.